this is a video that's going to work a couple of examples of finding the center of mass. So we'll do a pretty straightforward one first. I'm just going to give you a couple of particles. And we'll put mass 3 here, somewhere in between. And we'll go 8 kilograms. And we're going to stick an axis on here and a couple of locations, because that's important. So this is going to be, let's go 3 meters, this can be 4 meters, this can be 5 meters. And we are looking for the center of mass of this system. So I will do my x-coordinates first. X center of mass is going to be m1x1, m2x2, m3x3 divided by m1, m2, m3. So I'm going to get a 5 kilograms times 0. I'm going to get a 10 kilograms times 5 meters. And I'm going to get an 8 kilograms times 4 meters. Divide all of that by 5 kilograms plus 10 plus 8. On top I get 5 times 0 is 0, 10 times 5 that's 50, 8 times 4 is 32. So I'm going to get 82 kilogram meters on top. And on the bottom, 5 and 10 is 15, and 8 makes 23 kilograms on the bottom. When I do 82 divided by 23, I get 3.57, meaning the x-coordinate of my center of mass, right, if this is 2.5, somewhere my x-coordinate of center of mass is going to fall. The x-coordinate of my center of mass is going to be here, give or take. Then I want to do the y-coordinate of my center of mass. The y-coordinate of my center of mass, I'm going to have m1y1, m2y2, m3y3, all over m1 plus m2 plus m3. 0 for 1, 0 for 2, and then I'm going to get 8 kilograms times 3 meters. I'm going to divide that by still 23 total kilograms. 8 times 3 is 24, divided by 23 is 1.04. And I have a y-coordinate of center of mass that's here. So my center of mass is over here, and the coordinates for my center of mass happens at 3.57 meters, 1.04 meters. So I am to the right of center, which makes sense. I am below center, which also makes sense. That's the center of mass of these 3 particles. I want to do one that's a little more complicated too. I want to do one more. Let's find the center of mass of something like this. We'll go a triangle, and then we'll go maybe a smaller triangle attached to it, and just for fun, we'll attach a box. And now we need some dimensions. Let's do something like that, and then we can give these masses, right? So we can say this one is 10 kilograms, let's give this one 15 kilograms. and we'll give this one 6 kilograms. I'm going to look at each of these shapes individually. First, the block, because that's the easiest. The center of mass of that block is right here. That is at a distance of 3 meters from the end and a distance of 2 meters from the bottom, because it has to be the halfway point. A symmetric shape, that's always going to be easy to work with. Next, we're going to find the center of mass of this triangle. So to do that, I remember that for a triangle, it's a third of the way. This whole distance is 6 meters, so it must be here. So that this distance is 2 meters. And then this whole distance is 9 meters, so we're going to get something here. So that this distance is a third of 9 is 3 meters. So there's my center of mass of that guy. And then the last one. I've got a height of 6. So with a height of 6, I know I'm going to have something here. So that this is a third of 6 is 2 meters. And then I've got a width of 4. So something like that, so that this distance is a third of 4, which is 1.3 meters. And there's my center of mass. Now I can actually look at this as a coordinate system. So if I put a coordinate system somewhere, let's put it right through the middle. There's my coordinate system, x and y. Then I have these dots on my coordinate system, and I need to be able to pull those out. This first one, this is for my 15 kilogram triangle, and that is located at, my x coordinate is negative 2 meters. My y coordinate is positive 3 meters. My rectangle, this dot right here represents a 10 kilogram mass located at x equals 3 meters, y equals 0 meters. It's right on the axis. And then finally, this one, this represents a 6 kilogram mass at an x location of negative 1.3 meters, a y location of negative 2 meters. That means this is exactly the same as this. XY. I have one mass sitting here. Let's call that one mass 1. This is 10 kilograms. And this is at x equals 3 meters. I've got a mass sitting here, call that mass 2. 6 kilograms. This is at x equals negative 1.3 meters. Y equals negative 2 meters. And then I've got one here. This one is 15 kilograms, and this is at x equals negative 2 meters, y equals positive 3 meters. And I know how to do that. I actually just did a problem like that right up here. So I took this complicated shape, found the center of mass of each item, and said now I can reduce those to dots. Once I've got the dots, now I can find my center of mass. The x coordinate for my center of mass, x1, m1, x2, m2, x3, m3, and I'm going to divide by m1 plus m2 plus m3. So 10 kilograms, 3 meters, plus 6 kilograms times negative 1.3 meters plus 15 kilograms times negative 2 meters, and I'm going to divide that whole thing by the total mass, right? M1 plus M2 plus M3. 10 plus 6 is 16 plus 15 is 31 kilograms. The top, I've got 30. 6 times negative 1.3 is going to be negative 8. So 30 and negative 8, that makes 22. And then I'm going to subtract another 30. That's going to be negative 8 on top. Kilogram meters. Divided by 31 kilograms. And that gives me negative 0.26 meters. Then I'll do the same for my y center of mass. y1 m1, y2 m2, y3 m3 over m1 plus m2 plus m3. So y1 m1 is 10 kilograms times 0. y2, 6 kilograms times negative 2 meters. And then 15 kilograms times positive 3 meters. I'm going to divide all that by my total mass, which is still 31 kilograms. 0, 6 times 2 is 12, negative 12. 15 times 3 is 45. 45 minus 12 is 33 over 31. And 33 over 31 is 1.06. This tells me the center of mass of my item, of my whole big object, is at negative 0.26 meters for the x-coordinate, positive 1.06 meters for the y-coordinate. Now I made this coordinate axis, so I really need to go back to my original shape. If I go back to my original shape and I do some serious erasing, then I can find just where this is. This was, as a reminder, the center of the coordinate axis that I put on there that I made up. So at negative 0.26, that is here, just to the left of. And then at positive 1.06, this whole distance is 9, so it'll be something, well, this whole distance is 4, half of that's 2. So this part is 2, I am about halfway up that. So something like here. There is the center of mass of my whole system.